This conference will now be recorded.
Hey, hello. Good morning, everyone. I hope
Yeah,
I
yeah,
am
we can
audible.
hear you. Good morning.
Yeah, perfect. Okay, thank you. Yeah. So myself, Shankar, and right working as a lead DevOps engineer, one of the product-based company. And I used to give the trainings internal and as well as external trainings as well. So I have more than 8 years experience into DevOps. So I prefer number of projects where we can automate right, certain areas like build and deployments, infrastructure automations, right, logs management, security, like different roles. So simply this is about me, right? So today, right, we will discuss about the DevOps, and in the DevOps, right, what kind of roles we are going to play, and right, for that role, what kind of tool stack, right? So because there are plenty of tools available in the market in our area, in our DevOps area to work on the things. Right. So now the popular tools what we are going to use in our DevOps, and right, we'll discuss about those tools and we'll try to understand right our work area, like what kind of works we are going to manage in our DevOps. Right. So as a DevOps engineer, right, so like people used to call dev plus ops. This is the right, old definition, the dev plus ops, development, developers and operations, like that. So nowadays, right, so it's not like that dev plus ops or something. We are going to work for the automations, right? So DevOps engineers are going to work for the automations. The automations can be any area. It can be right any area. So suppose the build and deployment area. So there the DevOps engineer role is to right create a process by using the various tool stack, and right, so the process will take care of building and deploying the code into the different environments with less time, like with minimum time and effectively. Right? That's what our main job is. It's not like that. Simply we'll develop a process and leave it. Continuous improvisations. Right. So then the other area, suppose I'm talking about right, this is the kind of a build and deployment to manage your applications. Right. So the other area like infrastructure. Right. So like servers, load balancers, auto scalings, data storage. Like there are other areas are there where we are going to use those services to manage again the application effectively. Right. At the end of the goal is whatever the application you are working for, you have to manage, right? Apart from the development side, whatever the areas are there, like the build deployments, infrastructure, security, logs management, monitoring, like these areas, we are going to manage it. Right. Earlier, we are going to have different teams to manage these areas. Now the DevOps engineers, right, entered into the areas, then we are going to create a process. That's why, right, DevOps is not particularly to any one technology or something. It is a process. We are going to build a process, a culture. So where in one area you're going to use some set of tool stack, in another area, right, you're going to use some other tool stack. So now your tool stack is not constant. They're not static. So that right, you will always work with the same tools. Today you will work with some set of tools. Tomorrow that will be some different tools, right? So, but at the end, right, you are going to create a process. So that process is going to follow by right the teams, right? So that's why right our main goal, right? So the roles now we are going to play different roles here, right? If the project is it's a minimum project like is a level 3 company project, a simple project, there everything we are going to take care, like build deployments, monitoring, infrastructure management, all is the DevOps responsibility. If the project is somewhat huge, now the team is huge, like you have 10 more than 10 people of the DevOps engineers are there. then the areas are going to divide into pieces. Like build and deployment will take care by one part of the DevOps team, like 2 to 3 folks, and the infra will be taken care by again 2 to 3 folks, like that. Right? It depends on the project. Sometimes you are going to take care of everything. Sometimes you are going to work on a particular piece. Right? So now the area set, whatever the area, suppose, right? Let's talk about our build and deployment. So right, so when I'm going to talk about the build and deployment, right? Again, I need a process, a automation for the build and deployment. So there, right, what we are going to do in the build and deployment process, what we are going to do, right? So we are going to create a process, right? So the automation we are going to implement. So now what I need here to implement the automation, what I need, because right, it's not a new thing. So it's already there in the past. There is a team called build and release engineers. Right? So but by the time, right, very limited tools. The automation is not that much extent. You have only some limited tools by that time. So like Jenkins, Maven, shell scripts. Most of the time, right, people used to use the shell scripts for the automations. Right? With that, again, it challenges. So now, right, earlier the technology is not this much grow, right? So very less technology. So that app now technology is growing, servers are increasing, right? Tens to hundreds, hundreds of thousands. Now you have to maintain thousands of servers or hundreds of servers, right? So now with the shells or with the limited tools, that is not easy, right? Again, we can do that, but the time comes in the picture. Earlier, right, if I'm going to take 1 hour to deploy something onto some 2 to 3 servers, now 1 hour is very huge. Now 2 to 3 servers, now we are taking 1 hour, means it is not acceptable. That's what the current situation, right? So now earlier we have the process, today also we have the process, but it is much improvised process, right? So here you are going to save. It's not only just you are creating a process, it is going to save the cost, it is going to save the time. That's what that kind of process we are going to implement. Yes, as a DevOps engineer, it's not only creating a process, creating an automation. We have the other things, like your process should be taken care of, minimizing the cost, right, and the time. So that's how we have to build it, right? That's why, right, it's not like one time you develop and you are going to leave it always, right? So today I developed a process that is taking half an hour time. Now I have to think about it, right? Can I reduce it? Is there any other ways are there, right? So that, right, I can reduce the time, right? I can reduce the cost, right? The process now utilizing 4 services. Now why should I take 4 services? Can I work with the 2 services? So that, right, I can reduce the budget. So like, right, is always now you develop a process, and the, right, your core team or the followers, right, they will work on the improvisations, they will, right, they will make much better the automations. That's why, right, our process is always create. Our work is, right, our role, our area is, you will do something and you will always work on the improvisations by using, again, various tools in the market, right? So let's talk about the first area called build and deployment, right? So basically, right, what the DevOps engineers will do, right, whatever the application developed by the developers, right, they will develop the code for the application. From that, after the application code is ready, then taking the code, right, then checking the code, like applying some validations, then creation of artifacts, then finally, right, deploying to the different environments. Now the environments, nothing but the servers, make sure the servers are already ready with the required configurations, right? And on the servers, you are going to have a proper monitoring system, so that you are going to get the alerts immediately whenever something went wrong, right? So then we have to have a proper logging mechanism, so that, right, at any point of time, anyone anyone can go and check the logs. Likewise, that you have to create this kind of process. So that's why, right, very huge demand in the market right now for the DevOps folks who is having a proper technical knowledge on these areas, right, when compared to other technologies. Because, right, you are going to play multiple roles. As a DevOps engineer, right, you are going to play multiple roles. So then the DevOps engineers, right, what they will do, they will create the automations with the code, right? Not like we'll go with the GUI, click on next, 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 submit. Not like that. Every process with the code we are going to create, right? So like that's right. We are also like a developers, but not the application side. We are not going to develop the application, but the rest of the areas we are going to develop with the code only, right? So the guys who are having right some the coding knowledge and the services knowledge and the areas, right? So now they are like a leads in the market right now as a DevOps engineer, right? Now let's talk about right our first area called build and deployment process, right? So now usually right, so first part will be developing of the code. The first area will be right developing of the code. So now here we have the dev team and they are going to work on code development, right? Right now, right, I think you guys are aware of that applications are different types of applications: monolithic applications, microservices application, right? Whatever the applications right now, right, we are seeing right, they're all right now microservices application. Anyway, we'll discuss both, right? Suppose if I take Paytm website, right? So here you can see the services of the Paytm, right? Recharge, pay, right? Something like they're all in the back end, right? They will be work as a microservices, right? Right. So now here, whenever right, the team ready with the code, right? So as an example, so I'm going to right take the recharge of prepaid mobile, or let's take the simple one, right? DTH recharge. So DTH recharge. This is one of the service of Paytm application. That's another. They are ready with the code. Application. The developers are ready with the code of the DTH recharge. Now, what is the next step? It has to take and it has to provide to the users, like the customers, like we are the people. Now, can we take the code straightforward once the development is ready, then give it to the end users? No, right? Because what is the guarantee that the code is working fine, right? There are different things you need to see, right? What is the guarantee that the code is going to work fine? And what is the guarantee that, right, this code is not going to impact the other services, right? So now I develop the code, but my code is impacting the other services. My code is working fine, but the other services are get impacted, which means, so right, suppose right, the DTS recharge is the one which we developed. Now the recharge of prepaid the service performance goes down. Before this DTH recharge, it is responding right in milliseconds. Now it is taking seconds. Yes, performance impact, right? So now right, so now you have to see it not only your code, right? This either this code is right impacting any of other areas, and right, or this is this code properly developed with the security practices, right? The code is developed like that. We have to see the other areas. So then, what is the next step? We have to validate the code, right? So the code needs to be validated with the different scenarios. That's what called as a testing, right? So now this code is going to go for testing, and in the test it has to be passed, right? There we are going to run with different test cases, and the code has to be passed. So then this code again, right, the client, like whoever is the opportunity given to the right the team, so on the client side they will test the code and they should be satisfied. So then it will go to the live, right? So now the process, right, the process is once the code is developed, it has to go for right certain validations and then go for the testing, and the testing should be taken care by again different teams. Once all the teams right given the approval, then it will go to the live. So this process we are going to call it as a build and deployment process. In our right, in our terminology, we are going to call it a CA and CD process: continuous integration and the continuous deployment process. One of the right major area for a DevOps guys, right, is the CA and CD process, right? So like we discussed, right, applications, it can be right mono or it can be microservice, whatever the application it is, right? You have to set up the build and deployment process, right? So now further, right, earlier, like I mentioned, right, different teams are involved in the past, so to work on this application side. So like, right, designing team, development team, test engineers, deployment team, like our build and release engineers, operation team like admins, right? Likewise, different teams. Now, after the develop, right, the tester, then this is the area we are covering right now, the Devops works, right? So now, when there are multiple teams working in the past, right now the team's size got reduced. Now the team, like earlier, suppose in my religiousness there are 4 to 5 folks are there. In the operation side, 4 to 5 folks are there, like 10 people are there. Now the DevOps 3 to 4 folks, right? So when the 10 people are not maintaining it properly, these 3 folks or 4 folks can handle it. Again, right? No, it cannot. It's not that much simple, right? Earlier again, very minimum servers. Now the server size is huge, hundreds of servers. Again, 3 to 4, right? It's not easy. So that's why, right, tools playing very important role in our DevOps area. Right. So now we have plenty of tools available in the market to manage, right, this backend areas, whatever we are discussing right now. Right. So now what we will do, we are going to create a process, right? So for that, the first area called the CI/CD area, nothing but the build and deployment area. Right. Now let's try to understand, right, how we are going to set up this process and what is the tool stack, what is the purpose of each tool, we'll discuss right now. Right. So now, right, so now here, once the code is ready, then this code, right, what the team will do, they will place in a central position, which is called version control system. Is called version control system, right? So for that, we have number of tools available in the market, like SVN, Git, Bitbucket, Perforce, like that, right, to manage this versioning. SVN is one of the popular in the past. Now the Git taken that place. So now in the market, right, you guys will see Git, GitLab, Bitbucket, like that, right? They're all again to manage the code with the versions, right? So if you know the Git, if you know the Git, the same commands you will apply in the GitLab or your Bitbucket, the same commands. The UI part will be something you will see different, but the commands will be the same, right? So right, so now majority of the area you will see the Git, right? Because the model, the Git model is a distributed model. We'll discuss, right, what is the distributed, what is centralized model, what are the advantage of the distributed model. All the things we'll discuss in our actual classes, right? So now once the code is ready, the developers, right, push the code into the version control system. Why to push into the version control system, right? The naming itself, versioning, right, to manage the versioning, right? What is the advantage to manage the versioning, right? So right, so as an example, today, right, I worked on some change, right? The change is ready, then this change we deployed it, right, into the servers. After the deployment, it is not working. When I tested it, right, in my local, in other areas, it is working fine. When I deploy into the live, there is not working, right? So now if it is not working, then what is the immediate job for me? What should I do? One is fix the issue. Why it is not working? That is the first, right? The first thing for us. Now, how much time you need to fix the issue? 1 hour or 4 hours or 1 day or 2 days or n? Now, right, how we are going to decide based on the issue, right? If you go and see and if you're able to understand, then immediately can fix it up. But if you are not able to understand, then yes, it will go like that. But now that is not the proper solution right now, because the application is not responding, not working. Suppose take the e-commerce applications like Flipkart, Amazon. If they are not working for, right, at 5 minutes, how much business they are going to lose? right? So now your code is deployed and is not working. Now you are trying to fix it up, but you don't know how much time it will take, right? It is not acceptable. So now the first solution, right? Solution in the sense, the first approach eliminated. Now the second, what I can do? Revert the changes. Whatever the changes you did, right? Revert them. Bring back. If it is a one line change, two line change, right? Aram we can take it out. But if the changes are huge, like I worked for multiple files, in the files again hundreds of lines of code I have done. Then reverting those changes, right? Again, it is a tedious task. It is not that much easy. By mistake, right? If you revert, like if you remove some other code, that's it. And the second approach also, right, eliminated, because right again, if the change is small, that is fine. Otherwise, right, again it will create a problem. Time taken, there are chances are there it will create a problem by mistakenly if you remove something else. Then the third approach, maintain the copies, right? Always maintain the copies of every change. It's a single character change or hundreds of lines of change or multiple files of change. Maintain a copy. So when you maintain a copyright, then what we can do, once the latest is not working, then immediately take the copy and deploy it. Nothing but the backup, right? So that, right? So your application will be back with the old changes. That is fine, right? Application is up. Now when the backend work on the fix. So this is a proved approach. When something wrong, don't work on the fix. Don't try to revert. Revert in the sense, go and fix the issue. The code side, simply, right, take the backup and deploy it. Then work on the thing. Now who will take the backup, right? Okay, fine. So this approach is fine. Now who will take the backup of the code? Again, right? Someone has to take the backup of code. So there the version control systems came in the picture. Now, right, you don't need to worry about the backups, right? I will take care of it. Just give me the code. I will manage the backups, nothing but versionings. I will manage the versionings for you. Now your job is, right, focus on your changes. That's it. Right. So that's why, right? So now nowadays, right? Not nowadays, in the past also, right? So whenever, right, the teams are going to work on the code, they used to use these version control systems. Right. So earlier, right, majority of them, right, 80 to 90% the version control system for the developers earlier. Now it is not only for developers. We are also came in the picture. Like I mentioned, right, every automation you are going to do with the code only. Right. It can be your pipelines, it can be your playbooks, it can be your manifest files, it can be your Terraform code, whatever the code, right, you are going to place in our version control system only to manage, right, versioning. Like because we are also like a developers, but not the application level, from the infra level, from the build and deployment level, right, from the other areas. We are also a developers, right? So now once the code pushed, right, into the version control system, right? So then what we will do? So we'll take the code from the version control system, then we will go for certain validations, right? Like here, the first thing will be, right, unit test cases validation. So now, right, what is this unit test cases? Yes, now developers, right, once their code is ready, they will write the unit test cases to make sure their code is working fine and it is maintaining a proper code quality. Like I mentioned, right, it's not just only developing a code. We have to make sure, right, your code is properly developed. It is not impacting the other areas like performance of the application. Right, before my changes, application is responding in milliseconds. After my change, application is taking seconds, right? Not accepted even though your code is working. So that's why, right, they will create the test cases, right, so that to make sure their code is working fine and maintaining a good quality of the code. So for that, they will write the unit test cases. Now what we will write in our process? So, right, the first step will take the code from the Git. Then from the Git, once you got the code, you will run the unit test cases. Right. If the test cases are failed, suppose the process will be stopped. right? The process will be stopped there and will inform to the team saying that your test cases are failing. If the test cases are passed, right, then what we will do, we'll go for checking the code quality, right? So that, right, we are going to make sure the code is responding in a proper time and there are no security issues or bugs like that, right? So we are going to check the code quality. Again, if the code quality not passed, we are going to have gates there in the quality side. If the quality is passed, then we are going to go for the next step. Otherwise, stop the process and inform to the team saying that your code is not maintaining the proper quality. Make sure it has. Then again, right, the team has to work on the issues and again they will push back the code to the version control system. Once the latest code, right, comes to the version control system, again the process triggers like test case validation, code quality checking like that, right? So now suppose, right, the quality also good, then what we'll write, will create the artifact, right? We are going to create the artifact. What the artifact, right? Suppose that this is the DTH recharge as an example, right? The code developed in a file like dth.java. Like suppose assume this application is developed with the Java language. So now when comes to the artifacts, right? Right. So this will create the artifact into the different form like dth dot war file or jar file or er file, right? So right, so now here why we are going to convert it, right? So right, because at the end the application is going to run on the servers, right? The application is going to run on the servers. The servers are nothing but, right, the web servers, app servers, database servers like this. See here, right, this is an application which is running in a server on the back end. It can be, right, a web server. Whatever we are saying, right, it's from the web server. The content is delivering from a web server. Now the web server, right, requires, right, these artifacts, not like your .java files. The web server, right, requires the artifacts, not your raw code. So now what we will write, once the code we received, we are going to convert them into the artifacts, right? So then this artifact, what we will do, we are going to store it. Store the artifact, right? So now this process is going to called as CI process, continuous integration process. In our build and deployment, right, this is called as a CI process. What is the CI process? Whenever the team ready with the code, what they will do, they will push the code to the version control system. So then from that, right, we'll pick the code and we'll validate the code by running the unit test cases. If they're passed, then we'll go and check the code quality. If the quality also passed, then we'll create the artifact. And finally, the artifact, we are going to store it. So that it's a continuous process. Whenever changes are pushed, this process will trigger and it will go with all the steps, right? Or the tasks or the stages. So now, okay, fine, right? This process we are going to set up. Now, how we are going to set up, right? What is the technology or the tools or the languages we are going to use to build this process, right? So for that, right? So here the version control system we are going to use, right? The Git. And when it comes to, right, checking the test cases, right, the unit test case validation, we are going to use a tool like Maven, right? So since we are talking about the Java language, for every language we are going to have, right, different build tools. Like for the Java, right, for the Java language we are going to have Maven and like that. For the, right, if the code is developed with the .NET, right, then .ms build, .build like that. If the code is written in the Python, then PyBuilder, like, right. For every language, we are going to have their own or the language supported build tools. What is the purpose of build tool? Right, converting the code into the artifacts. Right. So now in the build tool for the Java, right, the popular one is the Maven from the Java side. Now the Maven has a capability. The Maven has a capability like it can validate the test cases also. The Maven can validate the test case also. It's not only creating the artifact, it can run the test case also. So now the test cases validation, I'm going to go with the Maven, right? So then the code quality, right? To check the quality of the code, like any bugs are there, any security issues are there, right? All the things we are going to validate under this code quality, right? So for that, we are going to use a tool called Sonar Cube, right? So now this guy will take care of code quality checking, right? So there we are going to place some gates, like I mentioned, right? The gates we are going to place so that the quality gate will be checked whether the code has good quality or not. If there is a good quality, the gate will be passed. If not, the gate will be failed. If the gate is failed, we are going to inform the team, right? So right, so now here code quality is passed. Then artifact creation. Now who will create the artifact, right? The build tools again, right? Here I am going to use the build tool called Maven, right? Because Maven has the capability like it can run the test cases, it can create the artifacts also. We don't require to use some other tools to run the test cases. So now storing the artifacts, like we are going to store the artifact, like whatever, right? Suppose dth.war file we created, the artifact, the war file, we are going to store it, right? So for that, Nexus is the tool, right? Now see, we created a process. Now the process by using various tools, right? So now I want to run this process, like take the code from the Git and using the Maven run the test cases, and using the SonarQube, right? Code quality checking. Then using the Maven again, right? Create the artifact. Then using the Nexus, store it. Now how can I run it? Because right, if it's a Java language, Java code, right? Simply I will take the code and I will run Java, then the file name, so that the code will be executed. But here it's not particular to one, different tools. Now how I am going to run these steps one by one like a process. There I don't want to involve like no human intervention there to run this process. Automatically they have to run one by one, these guys. So that's where we have a tool called Jenkins. We are going to call this Jenkins as a build and deployment tool or integration tool, like that. Now this entire process we are going to create under the Jenkins. Now this, for this in the Jenkins we are going to have a name called jobs. Now it is a one job. Now this entire process is a job in the Jenkins. Right. Now what is the job is holding? Right. This job is going to have different stages, like take the code, run the test cases, code quality checking, creation of artifact, and storing the artifact. And finally, right, you can send an email notification. Right. So now for the CA, right, now the tool stack, what we are going to use, like Git to manage the code, Jenkins to create the jobs, then Maven, right, to validate the test cases, to create the artifact, SonarQube for the code quality checking, and the Nexus, right, to store the artifacts for the CI, right. So I hope we are good until this CI process. Any questions or anything on this process or the tools, right, guys, let me know. I will clarify it again.
Yeah, hi Shankar. So this
Yeah,
is
sure.
specific for this one, right? But in real time we will be using different kind of tools also.
Correct. So right, so yeah, so like I mentioned, right, so there are number of tools are available in the market. Why we are targeting these tools means these are all open source tools, free. So right, so now the customers, they are open with the budget, like they can afford the budget. Then we can go for the paid tools. Plenty of tools available in the market. Like anyway, I will give some samples there. Now these are the free. You don't need to spend much, right? The budget on these tools. You can take them and you can use them. So that's why, right? So majority of the projects we'll see with the open source tools, because like the customers are not interested to spend some amount on these areas. They want to spend on the infra side, right? Because again, that is a very very important area for us, infra management, right? So now, right? So yeah, so the different tools are available. From the tools, these are the open source and popular tools right now in the market.
And how about like for JavaScript, what kind of build tool we will be using it?
JavaScripting, right? JavaScripting for
React
the
and
Java,
Angular.
React and Angular, right? So for that again, they have their own React. I think it is something is there. Let me recollect it again. For the Node, straightforward, you can use the Node build, right? You can go for the Node build for the Node.js applications. You can use it
Mhm.
straightforward. You don't have any separate build tools are there for them for the Node. I think React also same, right? You can go for Node build and it will create the dist folder, and in the dist folder, right, it will create all the artifacts, the dist folder. So then you can deploy into the servers like our Nginx or right, the other services. So because they are like particularly not to develop the entire application in Node.js and React.js. They are like a, right, the web server, the server side programming, you can use it, right, right, like in the backend side majorly. Again, right, so now whatever the technology we are going to work on, right, on the technology we have to see like what is the build tools are available, and based on the, right, we will go and work on them. Like yeah, npm, right, for the Node side and React side, npm build, npm I for installation of the packages, npm build for to build the code, like that. Npm is the one.
Shankar, one more question here. Suppose when it
Yeah.
comes to these open source tools, like
Uh-huh.
the organization maybe decided to use a set of tools for all these process, step-by-step process. But when
Uh-huh.
it comes to that new different organization, again, if
Uh-huh.
they are the tools are varying, so do we we will find big difference to learn or almost that
Yeah, so like most of the time, right, you will see the same process, like whatever we are going to configure, and the tool side also, right? Suppose if I'm going to take the build process as an example, right? So now in the for the if I want to create an artifact, now the build tool requires an input, right? So like in my case, suppose if I'm going to talk about the maven, right? So now the maven requires an input, nothing but in the form of pom.xml file. Now we'll pass that file as input to the maven, and it will take the file and it will process, then finally to create an artifact. Now if I go and take the ms build, like suppose now you are working for a .NET, now ms build. Now ms build is not going to have any kind of pom.xml file or something, but just it required the code as input. Now, right, input, what is the input you have to pass? That's it. That's what our focus is. Now, if I go and use the ant, now what kind of input I'm going to pass? If I'm going to use the .NET, my .NET build, or my MS build, what the input I need to pass? So that's it. Now your build tool will take care of it. Then finally, right, it will generate the artifacts. We'll take the artifact and we'll deploy it. Right, the process remains the same, right? Just we need to understand what the parameters I need to pass to use that tool. That's how.
okay, yeah, thank you. And also, like, do we really need to have any programming language to become a DevOps
Mm,
engineer?
No, Venkat. Right now, right? So that's what, right? So here, the tools are going to provide their own coding. Uh, I can say like coding side, the coding sections. So right. So for that, we don't require to learn any particular programming language like a Java, .NET, Python. But if you have the knowledge, that is helpful for you to write the code easily from the tool side. Like suppose if I'm going to take an example of Terraform, right? So Terraform uses the HCL, right, HashiCorp language. Now we don't need to learn the HCL language because, right, they will be in the form of resources. The code will be available in the form of resources, like a ready-made functions, right? So now our job, right, understand that code, that I mean to say the function, and what are the parameters we need to pass to the function, then how to use it. That area is required for us. right? So now in those areas, what kind of knowledge is required? If I want to place a condition, if I want to write in a loop, right? How to write a loop, how to place a conditions, that area's knowledge is important. That's it. So now if I go for like again the pipeline side of Jenkins, same thing, right? Jenkins also, right, as inbuilt code is available, right, in the declarator, then you can take the code and you can use them. For that, what are the inputs we need to pass, what are the required inputs, or what are the options, like those knowledge we required. Then again, right, if I want to apply the conditions loops, how can I do it? Likewise. So that's why, right, we don't need to have a particular programming language knowledge, but yes, we are going to write the code, whatever the code is providing by the tools. We have to learn them, like learn in a sense, understand them, and take them and use them. Anyway, right, we'll cover those things. We'll see
Yeah, thank you.
in our
Yeah.
actual classes. Yeah. Right. So fine then. So now, right. So here, these tools we are using to set up the CA process. Anyway, right, if you guys are interested, right, so this entire CA/CD process, like just now, right, I think Shyam asked, right, the other tools, right? If you guys are still like at the end of the course, if you are really interested, right, then I will show you this CI/CD process by using various tool stacks, right? Right now we are going to develop the CI/CD by using whatever we are going to cover right now, right, with all the tools. Then I will show, right, by using GitHub, right? GitHub has some its own CI/CD process, like GitHub Actions, like AWS, the clouds, they are offering their own CI/CD process, right? I will show, right, the different the areas, and we'll go to the like we'll go to the Git, we'll go to the AWS, and there I will show, right, how to build and deploy the code by using their services and their tools, right, to have like a kind of understanding, right, how the process we are going to develop here and how the process we are going to develop their areas, like on particular that areas, right? We'll see, so that, right, we'll have some good understanding, right? So now, after the CI process is completed, now you are going to have your artifact in the storage tool called Nexus, like this. Like here I have my dth.war file. Now what next? Once this artifact is available, now it has to go for validation, the code validation. Now where we are going to perform this validation? They are nothing but we are going to call it as a environments. Now your code is going to be validated on the environments, right? So now we are going to have, right, different environments like dev, QA, UAT, prod, like this. And in the environment, right, we are going to have, right, number of servers to validate the code, because, right, we are not the only one who is going to use the servers. There are different teams, right, continuously working on the development side. So they will need to validate the code. So for that, we require some good amount of servers, so that, right, they can run the code on the servers and they can validate it, right? So now here we are going to have the different environments, like this is my dev, and this is my QA, and this is my, right, UAT, and this is my prod live, right? So now these environments are going to used by different teams, like here developers, and this is our testing team, and this is, right, from the client side, client, and this is, right, our live right now, right, what we are seeing right now. So now, right, so now what I need to do, once this artifact is ready, take the artifact and deploy into the dev environment. Now that is our first step. Take the code and deploy it. Now straight away, can I take the code and deploy it? No, right? Because I need a mission or the missions. On the mission, I need all the pre-setup to run the code, right? If I, like, suppose, right, I have a Word document. If I want to open a Word document in my system, I need, right, OS like Windows, and then I need MS Office. Then I can open it. Without the Windows or without the MS Office, right, we cannot. Likewise, if I want to run this application on the server, you need the pre-setup. Like a server is required on the server, right? You need a OS, and you need the language, right? The supported language like Java. As an example, I'm telling here, right? So now to run this code on a server, right? Web servers like here, like a Tomcat. and a user to run the code. Like that, right? A setup is required. OS, Java, Tomcat, and a user. Now, right? So now this code we are going to run on multiple servers like this. So on this machine also, I need OS, Java, Tomcat, and user. Right. So suppose I need to test this code on 10 servers. On the 10 servers, you need the same setup. Now, how much time you require? If it is a one server, right? Hardly, right? I need 1 hour of time so that, right, I can set up everything. If 10 missions, then 10 hours. No, right? So now 10 hours is used. So then what? Whatever the time you have taken, like suppose half an hour you have taken the time to set up on one server, in the same amount of time, I will give it to you to set up on the 10 servers. How, right? How come it's possible? So that's why, right? No manual. Scriptings. Again, the scripting set you can write the scripts like shell or bash scripts and you can deploy it, right? It means you can run it on the servers. Now what they will write, they will go in a sequential order, right? It will go to server 1 and on the server 1 it will set up, then it will go to server 2 like that. Suppose that if each server is taking 5 minutes, then 10 into 5, 50 minutes, right? No, not like that. So now I want to set up everything parallel, not in a sequential order. So that, right, if I go parallel, 5 minutes is the time it is taking. So in the 5 minutes, all the 10 servers will be ready. So that's why, right, there are tools came in the picture like configuration tools. We are going to call them configuration management tools. They are nothing but Ansible, Chef, Puppet. Right. So now this configuration management tool, what they will do, they will take care of the server setup, like installations, right, or creations or removals, whatever you want, right? The execution mode is parallel. The biggest advantage, right? They will go and execute in parallel so that all the servers will be ready with the same amount of time, like 5 minutes or 10 minutes or half an hour, right? So now what we will do, right? Now we are going to create automations by using these configuration tools for the prerequisites or the pre-installations or the setup, whatever is required to run the application, right? So like Ansible, if I take an Ansible, right, we are going to call this a playbooks. We are going to write or we are going to create a playbooks, right? If I'm going to talk about it, chef, we are going to call them as a cookbooks. Anyway, right? So right now, right, Ansible is leading in the market right now. These two are gone, right? You are not going to see Chef and Puppet much. You will see the Ansible. So why the Ansible has become popular, right? Again, in our actual class, right, we'll discuss about it. Why the Ansible is popular, right? So now we will write playbooks, and the playbooks are nothing but, right, the setup to run your application. Whatever the setup is required on the server, it will take care of it. It can be one server, or it can be hundreds of servers, or it can be thousands of servers. It can be a number of servers, right? So then once the servers are ready with the setup, then we can go and deploy the code, right? So now who will deploy the code, right? So deploy the code in the sense, take this dth.war file and place in the server or servers. Again, right, you have to use, right, the Jenkins. If I'm going to use, right, Jenkins is the CI/CD tool. So there, right, you can use some plugins. Right? Again, the plugins have some challenges. Then you can write the scripts. Again, the scripts, what they will do, they will go run one by one, taking the time. Then again, right, I have the tool called config tool. The config tool has a capability. It is not only managing the servers, it can be used for the deployment purpose also. Now, if I take my Ansible, right, with the help of Ansible, I can make it the servers ready. And with the help of the Ansible again, I can deploy the code also, right? So it will take care of both the roles, server management and as well as a deployment also. We don't require to go for any other tools, right? So now once the code is deployed into the dev servers, now the development team validate the code on the server to make sure not only his service or her service like DTH, it is working with the other services, means the other services are not impacted. They are running as expected, and your code also running as expected. Likewise, right, entire application is going to be tested on this environment, right? So once, right, they are satisfied, then what you will do, right, you will take the code and you will deploy into the QA environment. Now again, right, on the QA, again we have the servers. On the servers, the setup is required. Now we will take care. Again, your Ansible or the config management tools will take care of the setup to make the servers ready. Right, then again, they what they will do, again those guys will deploy the code into the QA servers. Now, right, the QA team, right, the testing team, they are going to run the test cases, the test suits against the latest changes. If they found any bugs, right, they will raise the bugs and the validation will be stopped here. And the team has to work on the issues or the bugs. Then again, they have to push back. Again, the CA process will trigger. It will go like this. Then the latest code will be deployed. And again, it will go for the validation like this. Let's see, it is a continuous process, right? So suppose, right, so now the test case are passed. Then the testing team will give the sign off, nothing but approval. This code working fine, you can take it forward. So then, right, this code will be deployed into the user acceptance testing, nothing but the client side, right? On the client side, right, the client team validate the code, and again, right, they will approve or reject. If they approved, right, then what we will do, right, finally we deploy into the live, nothing but production, right? So now this process of deploying into servers and validation is called CD process, continuous deployment. So now what is the tool we added here, right, in the CD side? So the tool is nothing but our like Ansible, right? So now this is the tool stack we can use from the open source side. From the open source side, we can use for the CI/CD popular tool stack, right? Majority of the project you will see this tool stack. Now this application, right, whatever we discuss, it is a monolithic application. So what is this monolithic application, right? So like here, my application is a single package, right? So right, so now I will create one final artifact, nothing but right here paytm.var. And inside the paytm.var file, right, I am going to have the DTH, I am going to have the mobile payment, I am going to have, right, the other services, right? What else is there, right? Electricity bill, that's something like mutual funds as an example. Like all the services are going to be packed, right? So now what is the challenge or the issues with this a single package? If there is an issue with the mobile payment, like the mobile recharge, right? So since everything is in a single pack, if something is wrong with one, it will bring down the entire application, right? That's what the challenge with the monolithic application. If one guy is not working, it will bring down the entire application, right? So right, so now we have to overcome, right, because technology and the competitors, right, we cannot go with this approach. We have to overcome this. Now to overcome this, right, what is the solution right now I'm having? What I can do there? So now let's to overcome this issue. Now the solution is, right, now don't run them as a single pack, as a single entity. Run them individual, like run the DTS separate, run the mobile separate, electricity separate, right? So something like the mutual funds is not the best one here. So right, some other one, right? Gas cylinders, right? Like so DTH, and right, so electricity bill, then mobiles, right? Then gas booking like this. Run them individual, right? Now what the advantage you will get, right? If one is gone, the mobile, right? Not an issue because the others are running as a separate entities. They will be available for the end users. Only the mobile services will not be available. Your application will not be go down. Right? One of the biggest advantage with the microservices. And the other advantage, right? The other advantage, right? Earlier, when I want to develop this application, right? If I take the Java, I have to use the Java to build the entire application. If I'm going to take the .NET, I have to use the .NET. But here, right, since they are you are running them as individual services, you can develop the DTH, right, with the Java. You can develop, right, this electricity bill with the Python, like whatever you suitable, we can take them by using, right, different technologies. Like, right, the other advantage, right? So now whatever the applications, right, nowadays we are seeing, like they're all like microservice application, right? So now your application will be divided into pieces, and those pieces are going to run as an individual server and individual service. But at the end, at the end, they are part of your application only, right? So that's why, right? So here, right, when I go for paytm.com, right? So here I can go to the home page. From the home page, right, I can click on, right? Suppose if I go for recharge, right, it take me to recharge of mobile bill, right? So now this is the service name, recharge, right? So like, right, so if I go to, right, gas booking or something, right, this is the service name. So right, so now here what I can do, right, simply I don't need to go to the home page, straightforward, right, the app name slash the service name, so that it will take me to the service straightforward, right? You are going to reach the service individual, the particular service, right? So like right here, right, so now here how to take care of the microservices build and deployment, because, right, so this is that a single a pack file, so that it will create a single war file and you will deploy it. But here you have to have the individual pieces, right? We are going to have the individual pieces. Now how we are going to take them, right? That's where, right, Docker and Kubernetes came in the picture to manage the microservices, right? So I hope we are good until this the CI/CD of the Mono. If any questions, right, let me know, guys. So I'm rubbing out. Right. So now here, right, so when it comes to the microservices, this jar file war files are there, right? So they are now not like a jar files or war files. They will be, right, our Docker images. Right. So now you'll create an image for the microservice. In the CA process, now the artifact is nothing but your image. Now what is that image? The image is nothing but, right, whatever the service, suppose a DTS service, whatever the service we are working for. Now for that service we'll create an image. Now what the image is going to have? The image is going to have everything in the sense, right, from the server creation, creating a server, then, right, installing OS, then installing all the required tools, installing, right, all packages, creation of users, right, any changes in the configurations, then take the code, then build the code, then run the code. Likewise, in your Docker image, whatever the service, right, you are working for the service, whatever is required to run the service, right, whatever is required, we are going to place in the Docker image, so that we don't need to work with the Ansible or something like that to make sure the servers are ready with the pre-setup. The servers are ready with the pre-setup. So because, right, you are taking care of everything here from the server creation, from the machine creation, we are taking care of everything. You don't need to, right, take care of front. And what is the other advantage with this images, right? These images are going to provide by the developers. So that, right, so the major hurdle for us is the dependency management, right? So developers will use some dependencies to develop the code, but when you try to deploy the same dependencies, use the same dependencies on the environments, the code is not working. So these kind of issues, right, you are going to see, like most of the time you will see these errors, right? The code is working on the local machines, the code is not working on the dev. The code is working on the dev, but is not working on the QA, like that. Now what is the reason? The code is the same, but in the backend, right, whatever the dependencies we are using, version mismatches or the dependency compatibility issues. right? Or the dependency is going to have some other dependency. That dependency has the issue. Like right, we'll face these issues. Now once we got the issue right, again you have to go with the developers and you have to check with them and take the proper version or proper dependency and fix it and deploy it. Right. So now there is a time delay is there. You have to reach the developers by the time the guy should be available. If not, you have to wait for like that time delay will be there. Now this microservice side, this Docker files, the images are going to provide the developer. They know what exactly what kind of dependency, what version is required. They know they will take care. If anything wrong, again they have to fix it up. Simple, right? They have to fix it up. So likewise, the other advantage, so that your process become faster. The whatever the time gap is there, right? The delay, it is gone. Right. So right. So now here this images is going to have everything. Now what I need, right? I have to create a server with this image. Right. The image will take care of server creation to deploy. So now I have to run it. Now where I can run this thing, that is what our Kubernetes, the clusters. So now the environment, right? Earlier we are going to have the environment with the servers like this. Now these environments we are going to call it as a clusters. Cluster. Right? What is a cluster? A cluster is a group of servers. Again, a cluster is a group of servers like this. So now we'll call dev cluster, QA cluster, UAT cluster, prod cluster like that. Now who is that cluster? That is what our Kubernetes clusters. Right. So why we have to use these Kubernetes clusters? Because your application now is not running as a single entity. Now your application is divided into pieces. Now each piece is going to run as a separate server. Now to manage all these services and their servers, we need one guy. That is what the cluster. That's what our Kubernetes is. So now right, so now inside these missions, now what we'll do, we'll create right small servers, like see right, server creation, like small servers. Now these servers we are going to call it as a containers, Docker containers, right? So container is also a small mission, a lightweighted mission where everything, right, like I mentioned, right, in OS, packages, tools, users, configurations, code, and running the code, everything is going to have here. Right. So now when the Docker itself is creating the containers for us, then why should I go for the cluster separately? Because I can use the Docker and I can create a container. Right? Simply I can do it. Right. Again, why should I go for the cluster? Right. These clusters will take care of managing the application of what? Highly available, highly scalable. Right. So it's not only right just to create the server and run the application in the server. We have to write, like I mentioned, right? Devops guys is going to play different roles, right? So one is that build and deployment. That's what right we're discussing now. The other area, right? Infrastructure, managing the servers, highly available, highly scalable, secure, right? Proper storage, like that. So now when I deployed my application, like when I running my container or when I'm running my application server, you have to make sure, right? It is highly available and scalable. So now if one, right, so like the previous monolithic application, one package, one single entity, you will deploy into one server. If I want to maintain highly available, then what I will do, I will take two servers. On the two servers, I will run the entity, right? So that one service down, the second will be available, highly available. Right? Simple thing. I take two servers and run the code. Now when I want to the scalable, take two more servers, add two more servers and run your code. Scalable. Easy. But here, right, it is not one single entity, right? So my application has different services, like 10 services, 20 services like that. Now 10 services are going to run in a separate servers. Now the 10 servers should be highly available and the 10 servers should be scalable. Now see, your infrastructure become huge, right? So now that huge servers are the application, how effectively are going to manage? That's where the Kubernetes came into the picture, right? So it will take the burden of ours, like this management things. It will take care of it. Pass the proper instruction to the Kubernetes. whatever you want, it will take care of the rest. One of the beautiful tool, right, to manage the application like microservices. Like a lot of features are there. Anyway, we'll discuss how, like with automation, how effectively you can use these tools and how to manage this high available and scalable by using it. Right. So like that, so now the Kubernetes in the Kubernetes, right, will deploy the code in the clusters, and again the validation process remain the same. The teams are going to validate now on the cluster side. Right. So now for the microservices, right, for the microservices, so from the CA side, you will see again version control tool Git to run the job Jenkins. Right, so then to create the artifacts, right, you can use the Maven to run the test cases and the Sonar, right. These are all the common tools to check the code quality. Now to right, the artifact creation will be taken care by Docker, and the storing of artifacts will be right Docker Hub, storing of the images. Then for the CD, right, you will use now here Kubernetes for the CD side. Right. So right now this is the separate tool stack for the mono, and this is a separate tool stack for the micro. Right. So now in our classes, we are going to see both the applications, mono and micro, and we are going to create two projects. The project one is the complete CA and CD process by using whatever the tool stack, right, we discussed. By using this tool stack, we'll set up the complete CA and CD process and we'll run the application. And the second project, by using this tool stack, we are going to create the CI/CD. Then there will run our microservices. There will see microservices build and deployment process. Right, like that. So two projects we are going to cover. Right, the entire setup, right, from the real time side. Right? In the real time, how we are going to set up, in the same way we are going to set up in our area also, except the code. Right, in the real time, right, you will have some other code. Here we are going to take the sample code. The rest of the process integrations, right, we'll see from the scratch, nothing but, right, you want to have the Jenkins job. Now to have the Jenkins job, you require a Jenkins. Now how we are going to set up the Jenkins, right, from the point, we'll take care of everything. Like you will take the servers, on the servers you are going to install the tools whatever you want, then the tools we are going to integrate one and each other, then finally we are going to create this process, right? Everything we are going to cover it from the scratch. Right. So now one area, the build and deployment area, right, by using these tools we are going to set up for the mono and microservice applications. So any questions until now before going to our other area?
Shankar, you mentioned, I remember like you mentioned about Terraform also, where it is
Yes, yes,
down here.
yes, Shyam, right. That's what the other area, right? The other area we'll discuss. Now this is the area for the build and deployment process.
Uh,
Yeah, we'll discuss that. Yeah, in this area, right, in this tool stack or in this process, any questions, let me know, right? So we'll discuss it again. If you know, right, if you are good, then let's talk about, right, the other area like infrastructure, right, the infra management. Right, this is one area for us, and the other area infrastructure. Right, so now in the infrastructure, right, what we are going to manage, the important is servers. Like you will be having, like now we discussed about different tools and the process. Like as an example, right, I talked about Jenkins. So now I need a server to run the Jenkins. Right, we talked about SonarQube for the code quality checking. We need a server to run this SonarQube. We talked about Nexus to store the artifacts. We need a server. Right? We talked about, right, Ansible. Ansible required a control mission. Again, it need a server. Right, like Kubernetes. It's not a single server. It's a cluster group of servers. Right, see here. Now we are going to work with number of servers. Right. So now these servers, how effectively are going to manage, right? Effective in the sense, highly available, scalable, all the stuff, backups, proper backups, and everything. Right. So right. So now here from the infra side, servers is one important thing for us. So then load balancers. Right. So whenever, right, you are running the application, right, highly available, right? We are talking about highly available. Means suppose an example, two servers I have taken and on these two servers, my application is running. Right. So now people, right, customers like we, right, we are sending the request. Now whether my request has to go to this server or this server, right? Where I can send. How I am going to know? I have to send the request to this server, that server, right? That's where, right, you will be having a load balancer, right? So now what this guy will do? Whatever the requests are coming to the application, right? The load balancer will take it first. The request will go to the load balancer. Now this guy, right, will take care of routing the requests. So which server is available, it will take care of routing the request, right? Highly available. So right. So now we need a kind of, right, scaling, like auto scalings. So where, so whenever, right, the load is increasing, now these two servers are not enough to maintain the load. Automatically, right, automatically servers should be added so that they will take care of the extra load, right? We have to take care of auto scalings. So likewise, right, so we have to take care of storage, right? So the storage, like your database, suppose, right, you have to manage the users, the clients, you will be having a database, right? So like we need to manage the static data, like nothing but, right, images. So whatever the application, right, we are seeing here, right, you can see there are plenty of different images are there, right? These images, right, if I'm trying to store in the database, charge is huge. Now what I can write, so this can be, right, because they are static images, they are not dynamic. Now how we are going to manage the static data from the storage side, right? So we have to, right, take care of the storage. Then the security, right, your server should be secure so that hackings, right, so this can be handled effectively, right? So now when you're, right, apart from the build and deployment, we have to manage the infra. From the infra side, right, we have to take care of servers, load balancers, auto scaling, storage, security, then user management, right? User management in the sense, in the application, right, in the project, we'll be having the developers, we'll be having the Devops, we'll be having the admins, we'll be having the networking team, like different teams, right? Providing the access to the team on the services side, right? So like, right, so we have to take care of the other areas, like there are other services also there, but just to understand, right, I'm pointing these services. We'll see more services in our actual classes, right, from the infra point of view. Now, right, so now here, to earlier, right, we are going to use physical servers or virtual machines to manage everything, right? It is challenging job because, right, managing the servers, the virtual machines, only by that time is available is the scripts, the shell scripts or the bash scripts. Only those are available, right, with the help of the script teams. Our, right, our like previous folks, they wrote many of the scripts to maintain these things like scalable, available, security, and all the stuff, right? So now cloud came into the picture, right? So now the cloud offering, right, different services for us, like infrastructure as a service, software as a service, platform as a service. Right. Now, as a DevOps engineer, right, we required infra, right? We are going to maintain the other area like infra. So now what is required for us? Infra as a service. This guy is required for us, right? So you are working for a Google, right? Google Cloud. You are working for Azure. You are working for AWS or IBM Bluemix or Oracle Cloud, right? It can be any cloud. They are going to offer the same services, right? Maybe that the terminology you are going to see different. Like as an example, right? In AWS, I'm going to call the service as a instances. AWS instances. In the Azure or Google, we are going to call it a virtual machines, VMs. Likewise, the terminals will be different, but in the backend, right? In the backend, suppose I want to create a server, right? I'm going to use a region, in which region I want to run the server. Then I'm going to choose the image like OS. Then I'm going to choose the infra, like nothing but that server configuration, like how much RAM, how many CPUs are required. Then the networking, the security groups, then the size, likewise, right? Will be having the sections. The same thing you are going to see in the Azure, the same thing you're going to see in the Google or other clouds, right? So now If you know one cloud, working with other clouds will be easy because all the clouds are going to follow the same patterns, the same architecture. Maybe right, you will see extra features, options, or the naming conventions in the different clouds. Right. So right now in the market, right, AWS is holding majority of the share, like 60 to 70%. Like when you go and see, right, the number of projects will be on the AWS side. Right. Azure trying to give the a competition to the AWS, but not like right. They have right got some a good thing on the Azure Devops side. They have given some kind of framework. Right. Again, right, they are all the paid things, not the open source, the free ones. Right. So now, right. So now here, by using these cloud and the cloud services, right. So now we are going to manage our infrastructure, like whatever you want as a service. So now here, right, the requirement is we need to set up the dev environment, right? So now for the dev environment, suppose right, I need 5 servers, and the 5 servers, right, required a load balancer, and they required right auto scaling. So the auto scaling rate can go for max 10 servers, the auto scaling. So then right, they should be right backend. The servers needs like MySQL database. So then S3 buckets are required to store the static data like images or videos. So then right, I need the security groups so that right, the servers I will manage with secure, right. So like right, so now here, fine, like let's leave it. So like right, I need this setup to set up my environment like servers, load balancers, auto scaling like this. Now what I will write for every right, for every requirement here, like servers, we have a service called EC2. Right. Like we have a service called like load balancer. We have a service called right auto scaling. We have a service called RDS. We have a service called right S3. We have a service called VPC for the security. Like right, we'll use different services and then we can create this environment. How much time you need? Right. So right, different 5 to 6 services. So maybe like 1 hour, 2 hour to set up everything. Okay, fine. Two hours. Take it 2 hours. So then I need the QA environment with the same setup, right? So now how much time you need now? Again 2 hours? Now not acceptable because right, you are creating the same replica again. Maybe some minor changes with some minor changes, but you are replicating it again. Why 2 hours? Because I'm doing it manual, right? I have to go to the Google, the cloud console and right? Not accepted. Make it automated, right? I want to have some kind of automation so that at any point of time, anyone can create the environment by passing the required inputs, right? So there, right, the cloud is offering, right? Suppose I'm working with AWS, it is offering a service called Cloud Formations. Suppose that I'm working for Azure, right? In the Azure, right, we have something called templates, Azure templates. Likewise, they are providing services so that, right, with the help of the services, we can create the infra by using the code like a templates. So that at any point of time, if you want to create a new environment, simply I will use the templates and I will pass the inputs and I can create it. Perfect. So now next environment, how much time is required? Hardly minutes. Just pass the input and take it. Within 5 to 10 minutes, your environment will be ready. That's nice. So now, right, so now here in my project, as an example, web servers are from the AWS side and the database servers we are taking from the Azure. Likewise, it's a hybrid cloud. Few services from the other cloud and the few services from some other cloud. It's a hybrid one. So now to automate the services, now I need the cloud formation knowledge and as well as I need Azure templates knowledge also because I'm working with the both. Now see, that is what the challenge, right? I need to learn both, right? Again, you have some other cloud, Oracle cloud is there. Again, you have to see what is the Oracle cloud is providing the service for us. So that's where right, Terraform came into the picture, right? Now this guy, right? You don't need to learn the services of the cloud to create these automations. I will take care. Now the Terraform, right, compatible with almost every cloud, means you can use the Terraform with for any cloud. That's what the beauty of the Terraform. Now the Terraform code also damn easy, right? Just you have to understand the Terraform resources, then take them and use them like ready-made function, ready-made code, the Terraform. Right. So that's why Terraform become very, very popular to manage the cloud, the infrastructure. Now what we will do, we'll create the Terraform code and we'll trigger it. It can be Azure, it can be Google, it can be some other cloud. Right. So right, you don't need to learn the respective services, whatever is here. Right. So like right, so now the other area, right, the infrastructure, the infra automations, right, by using the cloud and the Terraform. We are going to make it automations. Right. So then the other piece monitoring, right? So monitoring to make sure, right, your servers and applications, right, monitored every minute so that at any point of time, if something wrong, immediately you have to get the alerts, right? So for that, right, we have different monitoring tools are available. So suppose you are working for a cloud like AWS or Azure, they are providing their services. Like here, CloudWatch is one of the service to monitor, right, the servers from the cloud side. Right. So now when it comes to this application, like our microservices, right, there in our Kubernetes, right, we have something called Prometheus, then Grafana. Right. These are again, right, to monitor our microservices. So like right, by using, right, these tools and the services, we are going to create the monitoring system. So that, right, at any point of time, if something wrong, right, we'll get the alerts. Right. So likewise, logs management. Right. So because, right, so plenty of servers and plenty of microservices, huge amount of logs are going to generate. Now going with individual service and checking the logs, again it's a tedious task. Right. Right. So now what we want, right, here, a kind of centralized location. Suppose, right, I am working, right, I want the Paytm logs. Now the Paytm is going to have, right, different services like recharge, mobile recharge, like that. Now each service is running in a separate container, means separate server and their logs. Now, right, so when I want to go for my Paytm log, then I need to go to each container logs. Now see, it is a complex thing. Suppose if I can route all the logs into one central location, right, so that I can go to the location and I can simply check it. And also, right, if anything is wrong on any service, immediately I can have something called alert mechanism so that I can get the alerts. Right. So that's why, right, we have something like, again, the AWS, the clouds are providing the CloudWatch again for this log streaming. And right, we'll see by using ELK, right, Elastic Search, Logstash, and Kibana to manage the logs effectively in the central location. Like both we are going to cover here for the logs management. Right, guys? So as part of our DevOps with AWS, right? So we are going to cover these areas: build and deployment, infra, monitoring, and the logs management by using whatever the tools we discussed. Right. So this is, right, so our course, and we are going to, right, we are going to work with 3 projects, 2 projects for monolithic application build and deployment, and microservice application build and deployment, and third one, right, by using the Terraform, how we are going to create the environments, infrastructure. That is our third project. Right. So these are the tools we are going to cover as part of our course, right, for the DevOps side. And these are the services we are going to cover from the AWS side, from the infra point of view. Right. So for each tool, so I am going to provide the material as a tool basis. So as an example, right, like this, right. So here, right, so if I'm going to talk about it, version control tool, Git, right. So right, you will get a document for each tool, right, with the screenshots so that, right, you can practice easily. As an example, right, suppose I'm working for, right, the bear git repository. So what is the command and what the output you will get it, right? So like, right, I have taken the screenshot so that your practice becomes easy. If I run the command, what is the expected output? So like that, for every tool, prepared a material, a document, right, like PPT, right, you will receive it for each service, for each tool. And from the right, the prerequisites. So we are going to cover each and every tool from the scratch, from the point zero. So that, right, you don't need to worry about, right, I need to learn this thing or that thing. If you have some Linux knowledge, that's an advantage for you. Otherwise, right, we'll start with the Linux commands only, right? We'll go and see the important commands in our day-to-day life. Then we'll start with our actual tools. So that, right, even though you don't have any knowledge, right, it's fine. We are going to cover everything from the point zero, right? So you will be creating the servers and you will be installing whatever, right, the process required and what are the tools we talked about, right? You guys are going to set up by your own, right? I'm going to guide you, right? And I will show you in the classes. You will do the same. So then finally we'll set up this, the CI/CD and everything, the tool stacks, like that, right? We are going to cover each and everything. So much of technical stuff we are going to see. It's not like, right, theoretical process we'll discuss and leave it. So we'll go and each tool will go to the deep dive and we'll try to learn, right, as much as from the tools, so that, right, you can usually compete into the real time folks with 4 to 5 years guys, minimum 4 to 5 years guys. You can easily compete with them with this technical stuff. That's what the guarantee from my side is. So right, so that's all about our demo, right? If you have any questions, anything, right, we can discuss. Right, how many containers, right, Sushan, right, can how much size of each container, right? So here, right, so this containers, uh, Sushan, right, it is depends on your cluster setup, the container thing is, right? So as an example, right, this is my cluster, and in the cluster, right, I have 3 servers are there, right? So each server capacity is, as an example I'm giving here, 2 GB RAM. Each server capacity, right, 2 GB RAM. So means total size of the cluster is 6 GB RAM. Right. So now I want to run containers inside the servers. So now, like, container means a service, like DTS service. Now that service, each service required 1 GB RAM. Now how many I can create? Max 6. Right, because the total size of the cluster is at 6 GB. Now each service size is 1 GB. So max you can create 6. Suppose that your container not requires 1 GB, it is hardly, right, 100 MB is enough. Right. So now 1 GB, right, for 100 MB enough means for 1 GB you can create 10 containers. Correct? For 1 GB you can create 10 containers. Now for 6 GB, 60 containers you can create. Now which means based on your container size, means container means not the container size, your service capacity. Whatever the service you are running inside the container, how much is required based on, right, the number of containers can be created. If my service is huge, require 1 GB, then max 6. If my service is very lightweighted, hardly 100 MB is enough, then 60. Now the containers, the advantage with the containers, it can expand, right? Means I can start with 100 MB. Now it requires some extra CPU or extra RAM, like 200. It can expand. So that, right, you don't need to put a hard limit there. Now, right, so now here I can start with 10 MB, 10 MB or 100 MB. Then whenever it needs more, right, resources, it will expand, right? So likewise, right, the containers works for us. Even, right, suppose if you put like that, now there are chances are there my single container can occupy 6 GB of RAM because it needs more. So like suppose there is a bug in the code. Now it is continuously running in the backend, the loops. Now the loops are utilizing the resources. Now, right, now what the container is doing, right, it is expanding like that. So start with 100, then 200, 300, 1 GB, 2 GB, 3 GB like that because of the bug in the code. Now what is going to happen at the end? This guy alone only it will occupy the 6 GB, then finally crash because your content has the capability like it can expand. Then I can put a hard limit also. We have the option. We have an option. We can put a hard limit. So right. So you can start with 100 MB. I know this guy needs minimum 100 MB. Can go for max 500 MB, not beyond that. So now I can put a hard limit. So like you can start with 100 and go for 500, then stop there. Even though you need more, I'm not going to provide. So that right, you can avoid the kind of crashes. Right. So like right, again, this all comes from the Kubernetes side. Like I discussed, right? Kubernetes, one of the beautiful tool to manage the microservices. Right. So like that. Yes. So it means that your application size. It's not like right, your servers or something. The containers depends on your application. Yeah. Any other questions? Yeah, no problem, sister. Anyway, right, we like I mentioned, right, these odd limits, right? So this auto scalings will cover in our right when you are talking about microservices. Technical, right? You are going to see it. So I hope, I wish we are good.
Yeah, somehow we got knowledge.
Perfect, Venkat. Fine then.
Shankar,
So
tomorrow,
yes,
what time it is?
it is 6 o'clock, Shyam.
And
6.
how long it is duration of this course?
It will
Sorry, I
be right.
didn't.
Uh, Sorry, Shyam. You are saying something?
No, actually, sorry. If you would have not given any prerequisite, I not went through it. I joined
No, no,
the
no,
call
no, no.
today
Actually,
itself.
no, the timings I have not discussed about. Yeah. So right, so
Okay.
6 to 7:30 is our like here they mentioned 7 a.m., but it is 6 to 7:30 because right we are going to cover plenty of topics and the tools. We required minimum 2.5 months time, and the timings from Monday to Friday morning 6 to 7:30.
And you're also
Maybe
having weekend batch also. The
no,
same.
Sham. Actually, I'm not taking the weekend
You're not
batches.
taking any weekend batch.
Yeah.
Weekdays
Maybe
only.
there are. Yeah, only weekdays, Monday to Friday only. That is also between 6 to 9 a.m. only.
Six to
My batch. 9 means I am running two batches. One is 6 to 7:30 and the other one is 7:30 to 9. So, yeah. But the
so
7:30
it's
batch is
1.5
already
hour duration every day.
1.5 hour, Sham. Right. So 6 to 7:30 or 7:30 to 9. Yeah. But this 7:30 batch, right, already it is almost complete 60% of the course. So, right. This is a fresh batch.
So this batch is going to start from tomorrow only, right?
Yes, Sham. Yeah. So Venkat not able to. Venkat, are you able to hear? I cannot hear
Yeah. I
Sham.
can hear you. I can hear you.
Yeah, perfect, Venkat. Yeah.
Only concern
So,
with the timings. We need to think of it.
okay. Okay.
Suppose if we are having around 7, 8 people below level, 5 to 10 between,
Mhm.
are you okay to conduct separate batch?
Like, yeah, I'm looking for the minimum head count of 10, Venkat, actually. So maybe, right? Yeah, if there's a batch of 10 people, right? Yes, we can plan for that.
Okay. I'll try to check with my friends.
Sure, Venkat. Yeah. Maybe, right? If you have some batch, like we can check with the organizer also if they can arrange, right? People folk, then we can start the batch. Yeah,
Sure.
yeah,
Thank you.
yeah. Yeah. So fine then. I think if no queries or no clarification, right? Maybe we can wind up for today and meet you guys tomorrow.
Yeah.
Yeah.
Thanks, Shankar. It was nice session.
Yeah,
Thank you.
yeah. Thank you. Bye bye.
Bye.
Yeah. Bye. Have a nice day for Sunday.